Alright guys, so questions की working करा दूंगा. First वाले part में they are asking us to define the term Tesla. See, so based on the formula F is equal to BQV, we can actually make an attempt to define the term Tesla. So zara wordings please देख लेना. So if a force of 1 Newton acts on a charge of 1 coulomb. Sorry guys. Yeah, just give me a minute. मैं ये phone दूसरे कमरे में देखकर आ जाऊं ताकि somebody else can receive this phone. I'll start the class in a minute or so. Sorry, yaar. All right. So I defined the term Tesla. So if a force of 1 Newton acts on a charge of 1 coulomb, which is traveling at a speed of 1 meters per second in the direction perpendicular to the field, then the strength of the field is said to be equal to 1 Tesla. Okay. Now, next part के अंदर, a charged particle of mass m carrying a charge of plus q travels with a velocity v. So mass is m, charge is q, it travels with a velocity of v in vacuum. It enters a region of uniform magnetic field of flux density B, as shown. The question further says that the magnetic field is perpendicular to the direction of the motion of the particle. And the fact that the path of the particle in the field is an arc of a circle whose radius is r. The particle enters the magnetic field, and basically the question says that the particle performs circular motion where the arc of the circle is of radius r. First part में explain why the path of the particle in the field resembles the shape of an arc of a circle. यार wording किस form में लिखते हैं ना, वो जरा देख लेना. So you should divide your answer into two fragments. So the first statement should be direction of velocity is perpendicular to the field. Therefore, the charged particle experiences a force. Okay, so the first factor, the velocity of the charged particle is perpendicular to the field lines. Consequently, the charged particle will experience a force. Second point, direction of this force will be perpendicular to the field as well as velocity. Therefore, performs circular motion. यार ये वाला बहुत कॉमन क्वेश्चन है और यूजुअली 2 to 3 मार्क्स का ये वाला पार्ट बहुत दफा रिपीट हो रहा होता है कि दे आस्क यू रीजनिंग और द एक्सप्लेनेशन विद रिगार्ड्स टू व्हाई द पाथ of the particle is going to follow an arc of a circle. So your answer should be very precise. So zara statements ko carefully dekh lena. So the first point was direction of velocity is perpendicular to the field lines. Therefore, the charged particle experiences a force. Then the second point, direction of this force is perpendicular to both the field as well as the velocity. Hence, the particle executes circular motion. Right? फिर नेक्स्ट वाले पार्ट के अंदर अच्छा यार मैं जब इसको अपलोड करूंगा ना तो ये सारी हाईलाइटेड लाइंस वगैरह इरेज कर दूंगा ताकि आप प्रॉपर्ली रीड कर लो. नेक्स्ट पार्ट के अंदर they are asking you to show that the radius is going to be given by the following equation. So remember in theory we did this working. Repeat कर देता हूं. That it is the magnetic force which is responsible for making the charged particle move in a circle. So magnetic force is equal to the centripetal force. The formula for magnetic force was BQV. And for centripetal force, the result was mv square upon r. So if you make r the subject, you end up getting this result. R is equal to mass times velocity divided by b times q. So, 1 + 2 × 10⁻⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻ ओके, नेक्स्ट वाला पार्ट देख लेते हैं। कुछ रिपीट करना हो तो प्लीज बताते जाइएगा। I'll need the answer of the previous part. So in part C, it says a uniform magnetic field is produced in a region labeled as PQRS, as shown in figure 6.2. The magnetic field is perpendicular to the page. At point X, a gamma ray photon interaction causes two particles to be formed. It further says the paths of these particles are shown in figure 6.2. So one particle goes one way, the pink one, and the other particle goes the other way. That's the green one. Okay, so there are two particles getting produced, and both of these particles are traveling in the exact opposite directions, and the shape kind of resembles more of a spiral rather than a circle. So first part where they are asking you, suggest with reason why each of these paths is in the shape of a spiral rather than the arc of a circle. Now, if you look at the formula, this is the same formula जो ऊपर proof किया हुआ था. From the formula, you would establish that radius and velocity are both directly proportional to each other. So what that implies is, therefore, as the particle travels slash moves in the field, its velocity decreases. So basically, as the particle travels in the magnetic field, you can expect the velocity of the particle decreases. Moeed ne पूछा, why does the velocity decrease, sir? Any particle traveling, उसके ऊपर resistive force तो लग सकता है ना? And that resistive force can eventually cause the velocity of the particle to reduce. So any moving particle, if it experiences some kind of a resistive force, then the presence of the resistive force will cause its velocity to reduce. Okay? So as the particle travels slash moves, its velocity decreases. And the fact that velocity and radius are proportional to each other. So velocity का decrease करना, मैं arrow बना रहा हूँ, consequently causes the radius of the particle to also reduce. Therefore, radius also decreases. So basically, this decrease in radius is the result as to why the shape of the particle, instead of following a circular pattern, it kind of resembles the shape of a spiral. See? So based on the formula, radius is proportional to velocity. So as the particle moves through the field, its velocity will reduce, and due to proportionality, its corresponding radius is also going to decrease, which is why the particle follows a spiral shape rather than following circular motion. Next part देख लेते हैं. So both of the next parts are basically in line with this diagram. So it says, state and explain what can be deduced from the paths about the charges on the two particles. See, so मैंने wordings क्या लिखी है वो देख लीजिएगा. So regarding the charges, we can say that they have opposite or unlike charges. And the reason for that is since they are moving or they are getting deflected in opposite directions. Okay, so the fact that both the particles are traveling in opposite directions, as in one particle goes downwards, from the diagram you can check, and the other particle kind of goes upwards. So the fact that the two particles are traveling in the exact opposite direction implies that the nature of the charge possessed by the two particles must also be opposite or unlike. अच्छा, second part के अंदर it says, what can we comment about the initial speed of the two particles? So if you look at the diagram, you should be able to recognize that initially they are both following more or less the same curvature. So look carefully at the green and the red curvatures. So I've constructed the red one. आप उसको compare करो with the green one. आई गेस आपको काफी क्लियरली नजर आ रहा होगा कि इनिशियली द रेडियस ऑफ कर्वेचर फॉर बोथ ऑफ दीज पार्टिकल्स appears to be pretty much identical. So follow the radius of curvature for the red path and compare it with the radius of curvature of the green path. So initially, it appears they are both following the same radius of curvature. Consequently, we can expect that the initial speed for both of these particles must also be identical. ठीक है, अब wording देख लो. It says same initial radius of curvature. ठीक है, I've shown that with the red color and with the green colored path. Same initial radius of curvature. Therefore, they must both be traveling with the same initial speed. सही. मैं डायग्राम पर से वो रेड वाला पाथ और वो ग्रीन वाला पाथ रहने देता हूं ताकि आप दोनों को कंपेयर कर लो. एंड ऑन द डायग्राम में मेंशन कर देता हूं सेम इनिशियल रेडियस ऑफ कर्वेचर देयरफॉर सेम स्पीड. सेम इनिशियल स्पीड लिख देता हूं. नेक्स्ट वाला देख लो. प्रोसीड करता जा रहा हूं आगे. स्क्रीन पे आ जाए पर रीड कर लो. Alright, so state what is meant by the term magnetic field. See, so in terms of definition, a region in which a moving charge experiences a force provided that it is not moving parallel to the field lines. So any region where a moving charge is likely to experience a force, provided that its direction of movement is not parallel to the field lines. B वाले पार्ट के अंदर रीड कर लो. A charge particle of mass m and charge plus q traveling with a velocity v in a vacuum, it enters a region of magnetic field of flux density b as shown. So mass m, charge plus q enters the region of magnetic field and performs circular motion. The magnetic field is perpendicular to the direction of motion of the particle. The path of the particle in the field is an arc of a circle of radius r. Once again, they are asking the same question. Explain why the path of the particle in the field resembles the shape of an arc of a circle. ठीक है, again the same wording जो मैं थोड़ी देर पहले repeat कर रहा था. Your answer should be something along these lines. First point, velocity perpendicular to the field. Therefore, charge experiences a force. Second point, the direction of this force is perpendicular to both the field lines as well as the velocity. Hence, it performs circular motion. Next part के अंदर, again they are asking you to show that the radius is given by this formula. So the same working. Make your magnetic force equal to the centripetal force. Formula replace कर दो. Make radius the subject. तो आपका result आ जाएगा kind of similar to the question which was done earlier on. Do we mention the term centripetal force? It's up to you. जो ऊपर की wordings है ना वो सारी की सारी होनी चाहिए. For 2 marks, this is what they want. अगर ये 3 marks का होता ना तो फिर centripetal force का एक extra mark होता. Otherwise नहीं. See? So if they would have given you the same question, Mohit, for 3 marks, then you would have had to include one more point. And the third point would have been that it is the magnetic force which is responsible for providing the centripetal force. So third mark उस वाले point का हो जाता. For 2 marks, this is what you need, जो मैंने screen पे show किया हुआ है. Okay, C part देखिएगा. इसको जरा carefully देखें. ये वाला part भी actually 2-3 दफा आपके papers में repeat हुआ हुआ है. Part C, that is. The question says, A second charge particle enters the region of magnetic field. आगे लिखा है, it loses kinetic energy as it passes through the foil. ठीक है, तो डायग्राम पे foil given है, and as it passes through the foil, it will lose its kinetic energy. The particle follows the path as shown. First part में, mark with an arrow the direction of the travel of the particle. देखें दो options हैं. I can either mark the direction of travel with the red marker. एक possibility ये है, और दूसरी possibility is the one which I'm marking with the blue colored marker. अब we are supposed to decide दोनों में से कौन सा वाला correct है. Now keep in mind, after passing through the foil, the question says it is bound to lose its kinetic energy. So I would go with the red path. And the reason for that is, if you compare the diagram, you can clearly see there is a larger radius for the red path. Compare the curvature. Therefore, we can say the speed is greater. And as it passes through the foil, so after passing through the foil, its kinetic energy will decrease, its velocity will also decrease, so its radius must also decrease. So the red path correctly shows you the direction in which the particle was traveling. कैसे जज किया वापस देखो? The red path appears to be of a larger radius of curvature. So we can expect that for the red wala path, the particle must be traveling faster. Then after it passes through the foil and reaches on the other side, that's the black one. So after passing through the foil, as the question says, you would expect its kinetic energy to decrease. So therefore, its velocity is also going to decrease. And hence, its radius is now going to become smaller. See? So, जी रेखा मैं वापस repeat कर रहा हूँ. Oh, okay. Okay, as in you got the idea? Or do I need to repeat myself? Nonetheless, I'll repeat it. So for the rest of you guys as well, मैं फिर भी repeat कर देता हूँ just in case. So, you know, the red wala path जो है, that appears to be of a larger radius of curvature, which means you would expect the velocity in the red wala path to be of a greater magnitude. Now, as it passes through the foil and goes towards the black path, so after passing through the foil, you would expect the kinetic energy to decrease. Consequently, the velocity will also decrease. So you would expect the radius to decrease. Okay, so between the two options which I went, the red versus the blue, I erased the blue one and I've left the red wala path to be the actual path followed by the particle. So yes, I think Rohil ki wording sahi hai. Velocity is decreasing, causing a decrease in the kinetic energy. Sounds right. Okay, so it should be going from a larger radius towards a smaller radius to imply the fact that its velocity from a higher value is going to drop down to a lower value once it passes through the foil. ठीक है guys, I'm hoping कि आपने follow कर लिया statements को. So first part में they were just asking us to mark with an arrow ना, we have done that. Second part देख लो. मैं थोड़ा सा scroll up कर रहा हूँ for the second part because I'll need the formula from the top. So in the second part it says कि आपको radius की value given है. So on one side the radius is 7.4. ठीक है. And on the other side it's 5.7. So I should be calling this as the final radius because this is of a lesser value, the black one. And I should be calling this as the initial radius because the value is larger, the red one, so as to say. मैंने black और red का ही combination use किया है ताकि आप diagram के साथ इसको correlate कर लो. The question is asking you, how much is going to be the final momentum upon how much is going to be the initial momentum? अच्छा, मोमेंटम का एएस से कोई ताल्लुक नहीं है, with the exception of the fact that you just need to know momentum is mass into velocity. So from the formula which I'm circling, if you make momentum the subject, if you make m times v momentum the subject, you'll end up getting this answer, mv, which is actually a momentum, can be written as जी, मेरी स्क्रीन पे रोहिल ने सही सजेस्ट किया हुआ है, b times q times r. So mv, which is momentum p, it is equal to b times q times r. So final momentum should be b times 2 times the final radius 5.7. Let me write this with a black color ताकि आप डायग्राम को डिस्टिंग्विश कर लो. एक सेकेंड ना, सॉरी. So the final momentum will be b times q times the final radius 5.7, the black one, and the initial momentum will be b times q times the initial radius, the so-called red one. So वो red वाली value was 7.4. तो simplify कर लेना यार. The rest of the functions will get cancelled out, and the final ratio can be worked out. I'm getting the answer 0.77. Thank you, Ali. Since it's a ratio, so I have not converted centimeters into meters. Next वाला देख लेते हैं. रीड कर लो, आपकी स्क्रीन पे भी आ जाएगा. स्टेटमेंट प्लीज पढ़ लेना. जो रेलेवेंट है ना, मैं सिर्फ उनको हाईलाइट कर रहा हूँ. बाकी स्टेटमेंट्स आप लोग रीड कर लो. In the question they are asking us, रीड पूरा कर लो और मैं मीनवाइल डायग्राम की कंस्ट्रक्शन कर लेता हूँ. ठीक है, so basically they are asking you to show uh, a diagrammatic representation of 4 magnetic field lines to represent the magnetic field due to current in the wire labeled as A. A के लिए current is coming out. Remember, current coming out was denoted by the symbol of dot. And if you recall, the magnetic field का direction आपके पास dot के केस के अंदर anti-clockwise होता था. ठीक है, ये वो O levels वाली working है. So current coming out, if you use the grip rule, mention कर देता हूँ. So for current coming out, the magnetic field will point in the anti-clockwise direction. Draw भी कर देता हूँ साथ साथ. So this is how the diagrammatic representation would look like. Draw the first few lines close to each other to imply the fact that the field is more concentrated when we are closer to the wire. And then as you keep moving away, since the strength of the field will decrease, so the concentric circles should move far apart. So anti-clockwise, first point, yeah, first mark. Circular concentric circles, second mark. And the fact that they are concentrated when we are closer to the wire, and the gap between them increases as we move further away from the wire, third mark for that. Okay, so concentric circles, one mark. Pointing in the anti-clockwise direction, I'll just mark that on the diagram, second mark. And more concentrated when we are closer to the wire, and as we move further away, the strength of the magnetic field decreases, so the concentric circles will keep moving far apart from each other. Arrows में बना दूं before I proceed. एंटी क्लॉकवाइज के लिए काइंड ऑफ इस तरह का हो जाएगा. इतना काफी है. सही. नेक्स्ट पार्ट के अंदर डायरेक्ट करंट आप लोग रीड कर लो. जो रेलेवेंट है ना, वो मैं ड्रॉ कर देता हूँ. So the question says a direct current is now passed through B in the same direction as that in wire A. So wire B is now supposed to be carrying current in the same direction. I'll mark that. So wire B is also carrying current in the same direction. And the question is asking us to mark the direction of the force. So remember in the last class we discussed that like currents always attract each other. So let me just mention that terminology somewhere over here. Like currents attract. So you are expected to mark the direction of the force. Attraction के लिए diagram पे देख लेना. I'm using this mustard color to mark the direction of the force, so it becomes kind of prominent. Okay, so like currents are supposed to attract each other. You are supposed to mark the wire. You are supposed to mark the force on wire B due to magnetic field produced by the wire, produced by the current in wire A. Okay, so force on B. So since like currents attract each other, so the force on B must be towards the left hand side. कुछ repeat करना हो तो please do let me know. Next part के अंदर it says wire A also experiences a force. State and explain which wire, if any, will experience a larger force. I'm hoping last class से आपको याद होगा कि between the two wires A and B, which wire do we expect to be experiencing a larger force? Let me quickly go back to the notes तो verify भी हो जाएगा. Okay, so diagram पे देख लो. मैं notes में से जो मैंने last class में करवाया था ना, I'm going right at the end. तो शायद possibly आपको याद आ जाए. If you read this, you will know what we are dealing with. ये हमने last class में किया था. शायद याद भी होगा कि which wire experiences a larger force. जरा statement in case if you were not there, जरा read कर लो. That since force is directly proportional to I1 into I2, that is force is proportional to the product of the two currents. Therefore, both wires will be experiencing the same amount of force irrespective of the current in each wire. जो हमसा ने आंसर दिया है ना, that is correct. उसको proper wordings में frame कर देता हूँ. So force is directly proportional to the product of the two currents. This is based on the formula that we did in the previous class. Therefore, each wire experiences the same amount of force. Okay, next वाला part देख लो. थोड़ा सा इसको scroll up कर रहा हूँ. The direct current is now replaced by alternating current of equal peak values. The currents are in phase with each other. So now the direct current has been replaced by alternating currents, and both currents are in phase with each other. Describe the variation, if any, of the force experienced by the wire B. Okay. Once again, let me go back to the theory part ताकि आपको याद आ जाए कि हमने इसकी भी wordings पे लिखा हुआ था. So if the direct current is replaced by alternating currents, let's see what happens. So I'm just shifting back to the previous slide, the one that we did in the last class theory. So this is the working which we did, that if both wires are now carrying alternating current instead of direct current, then this is how the shape of the individual currents would look like. And the graph for the force is the one which I'm highlighting with the green colored marker. They have not asked us for the graph, rather they have asked us for the explanation of the graph. So the explanation is the one which I'm highlighting again with the green color. So ये wordings हमने previous वाली class में लिखी हुई थी. Statement देख लेना. So they are not asking us to write down the graphical representation. Rather, they are asking us to give an explanation for the variation of the force. So the wording which I've highlighted with the green marker for alternating currents, for AC currents, the force varies twice. Last class से याद भी होगा. Between maximum and zero for one complete cycle of current. Okay, so this is how the answer should be given in case if the wires are now carrying alternating currents, and if the question asks you to state or suggest or explain for that matter, how would the force vary as a function of time. वो जो green वाली highlighted lines है ना, उनको follow कर लो. मैं wordings को यहाँ include कर लेता हूँ. For one complete cycle of alternating current, comma, the magnetic force between the two wires, between the wires लिख लेता हूँ, थोड़ी जगह कम पड़ेगी ना इसलिए. The magnetic force between the wires varies between maximum and zero twice. Okay, so the question was asking you, how would the force vary if the wires are carrying alternating currents? Okay, so the wording should include the term that the force varies between maximum and zero. Secondly, it should include the term this variation occurs twice. यार ये सारे statements relevant हैं. Force varies between maximum and zero. Second point, it varies twice. Third point, this variation takes place over one complete cycle of alternating current. Say force varies between zero and maximum, 1 mark for that. This variation occurs twice, 1 mark for that. And the third mark for stating that this variation is occurring for one complete cycle of alternating current. सही. रोहेल ने सिर्फ ट्वाइस लिखा था, तो ट्वाइस के साथ साथ मैक्सिमम एंड जीरो भी आना चाहिए और ये वाला पॉइंट भी आना चाहिए कि दिस इज द वेरिएशन दैट इज टेकिंग प्लेस फॉर वन कंप्लीट साइकिल ऑफ ऑल्टरनेटिंग करंट. मैं हाईलाइटेड लाइन से इरेज कर दूं, आपके लिए थोड़ा सा रेडेबल हो जाएगा. जस्ट अ मिनट. ओके, नेक्स्ट वाला क्वेश्चन. ये वाला पार्ट स्ट्राइक आउट कर देता हूँ. दिस इज फ्रॉम द नेक्स्ट टॉपिक, तो ये भी इग्नोर कर देते हैं. ओके, पार्ट बी से करा देता हूँ. आप रीड कर लो, मैं इसके ग्राफ की डिस्कशन कर लूँ. For those of you who missed out the classes now, तो यार इस टॉपिक के अंदर हॉल प्रूफ वगैरह की जो वर्किंग है और जो क्रॉस फील्ड की वर्किंग है, वो दो चीज़ें बहुत इंपॉर्टेंट हैं। तो प्लीज़ टेक आउट सम टाइम कि वो लेक्चर्स की रिकॉर्डिंग वगैरह सुन लेना, फॉर दोज ऑफ यू मिस्ड आउट द क्लासेस। लेट मी रिपीट माई सेल्फ। हॉल प्रूफ वाली जो वर्किंग है, वो इम्पॉर्टेंट है, और क्रॉस फील्ड वाली जो वर्किंग है, दैट इज इक्वली इम्पॉर्टेंट। Okay, so in the question it says a large horseshoe magnet has a uniform magnetic field. I'll just highlight the relevant terms. Has a uniform magnetic field between its poles. The magnetic field is zero outside the space between the poles. So it's uniform between the poles and it's zero outside the poles. A small Hall probe is moved at constant speed along the line XY, that is midway between and parallel to the faces of the poles of the magnet as shown. So we are moving a Hall probe from position X going towards Y. X to Y जा रहे हैं. An EMF is produced by the Hall probe when it is in the magnetic field. EMF refers to जो हमने notes में किया हुआ था Hall voltage, which was denoted by the symbol of VH. The question is saying that Hall voltage is getting produced when the Hall probe moves in between the magnetic field. The angle between the plane of the probe and the direction of the magnetic field is not changed. On the axis of figure 5.2, sketch a graph to show the variation with time of the Hall voltage. Ryan ने आंसर सही दिया है. His statement is 0, maximum, then again 0. ठीक है, और मैं थोड़ा सा क्विकली नोट्स में से आपको रिकैप करा दूं कि we actually constructed a similar graph. आपकी स्क्रीन पर आ जाएगा. ठीक है, तो काइंड ऑफ सिमिलर, इनफैक्ट एग्जैक्टली आइडेंटिकल है. So this is the initial position of the Hall probe. It passes through the region of the magnetic field. So first stage, there is zero magnetic field, so no voltage. So the graph will be at zero, जो I think Ryan ने पहले लिखा था. फिर middle वाला section, there is a constant magnetic field, so constant voltage. And then the third section, again there is zero magnetic field, so zero voltage. तो पहले zero, फिर maximum, फिर दोबारा zero. So if you guys are okay with this, मैं ये highlighted diagrams को erase कर दूं, ये थोड़ा सा untidy हो गया है. And I'll directly move on to the shape of the graph. ठीक है, it should be appearing in front of you. I think रोहेल ने भी सही wordings लिखी हुई हैं. Before the probe enters, stays at zero. So no magnetic field, hence no voltage recorded by the Hall probe. फिर middle वाला section, constant magnetic field, so constant voltage recorded by the Hall probe. So horizontal straight line kind of. और फिर पता नहीं क्यों straight line नहीं बन रही है और मैं irritate होता रहूंगा. This is about it. और फिर when it exits or leaves from the other side, so again zero. ज्वाइन करना होना तो वो आपकी चॉइस है. बीच के लाइंस को कनेक्ट कर देना, इट्स अप टू यू. करना हो तो कर दीजिएगा, अदरवाइज इज फाइन। ठीक है, सो 0 in the beginning, 0 in the end, and a maximum constant value as it passes through the region of the magnetic field. Next वाला। ठीक है, आप लोग वर्डिंग्स रीड कर लो, मैं ये वापस नहीं लिख रहा। I'll just write down same statements as above. ठीक है, रिमेंबर स्टेटमेंट्स क्या थे, मैं क्विकली बोल देता हूँ। Velocity was perpendicular to the magnetic field, therefore the charged particle experiences a force. 1 mark for this statement. Second mark, the direction of the force is perpendicular to both the field and the velocity, hence the particle performs circular motion. So 2 marks हो जाएंगे. Same statements as the ones which I stated earlier on. और मैं जिस तरह मोहित को कह रहा था कि if the question would have been for the 3 marks, so then for the third mark, you must mention that it is the magnetic force which is responsible for providing the centripetal force, if for 3 marks. Otherwise, the same 2 statements which were mentioned earlier on twice in 2 different questions in today's class. ठीक है guys, I'm hoping कि वो आपको statements याद होंगे from the top. Next part के अंदर, the angular speed is omega. Derive an expression for omega in terms of so and so. So magnetic force equals centripetal force. Magnetic force will be BQV. Centripetal force will be MV omega. I'm purposely going with this statement because this will allow me to cancel the term velocity from both the sides. I know I have to cancel out the velocity term because the question only wants me to give the answer in terms of these 3 functions. So I purposely went with MVW ताकि मेरे पास V का term cancel हो जाए. सही, और I only want the answer in terms of B, Q and M. So I believe वो तीनों terms आ गए हैं. Make omega the subject, you end up getting this answer. रोहिल, तुम्हारा statement सही है. नेक्स्ट वाले की वर्किंग देख लो. State the condition for a charged particle to experience a force in a magnetic field. 2 points बताना. First point, it must be a moving charge. Stationary नहीं होना चाहिए, otherwise no force. It should be a moving charge. Second point, its direction of velocity must not be parallel to the field lines. Okay, so the charged particle must be in motion. And the second point, the direction of velocity should not be parallel to the field lines. Okay, otherwise force 0 हो जाएगा. Next part के अंदर wordings देख लो. They are asking us to state an expression for the magnetic force. Direct answer लिख लेता हूँ. Symbols की explanation खुद कर लेना. ठीक है, just write B for magnetic flux density, Q for charge, V for velocity. Sorry. So I just repeated that ना कि B for magnetic flux density, Q for magnitude of charge, V for the speed of the charged particle. ठीक है, मैंने नहीं लिखा, but I've just verbally stated that कि symbols की explanation क्या करनी है. Alright, Reha? सही है. Next वाला part देख लेते हैं. So this time around, they have given you the structure of a Hall probe. अब ये थोड़ा सा carefully देखना कि इसकी working कैसे करनी है. मैं लिख भी देता हूँ. So इसके अंदर जो Hall probe की पूरी working हमने notes में करी हुई थी ना, उसकी थोड़ी सी usage आ जाएगी. So in the first line, they are asking you, read आप लोग कर लो. So in the first part, they are asking you, shade the sides to which electrons will move as a result of this force. आप पूरा read कर लो पहले. मैं तब तक details लिखता जा रहा हूँ. So magnetic field, which is the second finger. तब तक आप पूरा read कर लो. The magnetic field, which is the second finger, should be pointing in the downwards direction. ठीक है, the red statement goes with the red arrows. Just in case if you're wondering ना, तो मैं थोड़ा सा darken कर देता हूँ. So magnetic field, the second should be pointing downwards. Okay. Magnetic field, which is the first finger rather. Sorry. Magnetic field, which is the first finger, should be pointing downwards. Second statement. Current, which is the second finger, must point to the right. In case if anyone is wondering, why is the second finger pointing to the right? It's pretty obvious. Hai? Electrons are moving to the left. So if you guys are okay with the statement that electrons are going to the left, then we should expect the current, which is the second finger, to be going to the right. Electrons are going to the left. So current, which is the flow of positive charges, must point to the right. So दो चीजें हो गई. अब लेफ्ट हैंड अप्लाई करते हैं. मेरे स्टेटमेंट प्लीज केयरफुली देख लो ताकि कुछ रिपीट करना हो. सो आई विल डू दैट. So let me repeat myself. Magnetic field, first finger, points downward. So current, the second finger, must point to the right. Why to the right? Electrons are moving to the left. So current must definitely point in the opposite direction, that is to the right. So now, अगर आप लोग अपने hand placement करते हो, so basically Fleming's left hand rule. तो आप जरा प्लेस करके देख लीजिएगा और किसी को सजेशन देना हो तो you'll have to place your hand and then give me a suggestion. So first finger on magnetic field points downwards, so towards the bottom of the screen. Second finger for current, which is supposed to be opposite to the direction of electron. So electron is going to the left, so current should go to the right. So दो चीजें हो गई. मेरे केस में the thumb is pointing into the screen. So that means the force is going to be into the screen. तो ये थोड़ा सा काम आपको करना पड़ेगा by the placement of the left hand. तो मैं वापस से रिपीट कर रहा हूँ और गाइस थोड़ा सा मुझे फिर ओके कर देना कि you have understood. तो मैं रिपीट वापस कर रहा हूँ. First finger for the magnetic field, that's the red arrows pointing downwards. Second finger for current, since electrons are going to the left, so current, which is a flow of positive charge, must be going to the right. So left hand के अंदर, your first finger should point downwards towards the bottom of the screen. Your second finger should point to the right of the screen, rightwards. And if you try to arrange your hand, then your thumb should go into the screen. And if you guys are okay with that, मैं लिख देता हूँ into the screen. Then this would implicate, the question was asking you, shade the face in which direction you expect these electrons to move. So यार into का मतलब है मेरी shading ये हो जाएगी. Let me just look for a suitable color. Orange कर देता हूँ. येलो ही सही है. So यार मैंने शेड तो कर दिया है. BCGF makes sense. ठीक है, ये तो फर्स्ट पार्ट था. ओके, सेकंड वाले पार्ट में देख लेते हैं. तो गाइस कुछ रिपीट तो नहीं करना ना. रिहा, यू आर ओके विद दिस पार्ट बेटा? कि आई हैव सजेस्टेड हाउ टू पोजीशन. ठीक है, परफेक्ट. ऑलराइट, फिर यार द नेक्स्ट पार्ट सेज द मूवमेंट ऑफ द इलेक्ट्रॉन्स in the magnetic field causes a potential difference between the two faces of the conductor. So, using the letters from this figure, state the faces between which potential difference will occur. So, बहुत simple है. If electrons are going towards the yellow shaded side, then you would agree that the yellow side can be labeled with minus signs just to show the accumulation of electrons. And remember, in the notes we suggested that if the side into the screen gets an accumulation of negative, then surely the side on the front of the screen can conversely be stated to be carrying positive charges. Let me repeat myself again. If electrons are showing a tendency to go towards the yellow side, so yellow side ke upar there is going to be a development of negative charges. So that is as good as saying that the blue colored side, which I'm marking right now, is going to have an accumulation of positive charges. Because negatives on one side is equally as good as saying positive charges on the opposite side. So if electrons are getting accumulated towards the yellow side, then that is as good as saying that there is going to be a accumulation of positive charges on the front face. That's the blue one. The question is not asking me to highlight it with different colors. Rather, the question is just telling us to shade, to state the faces actually between which the potential difference will occur. So again, repeat kar raha hu. If accumulation of electron causes the yellow shaded side to be negatively charged, then the opposite side, the one shown with the blue marker, should show an accumulation of positive charges. So consequently, मैं लिख देता हूं इस तरह से, ये the blue shading as well as the yellow shading. मैं शेडिंग इरेज नहीं कर रहा और अल्फाबेट्स की भी लेबलिंग कर देता हूं. This was the entire working of a Hall probe, if you remember. अच्छा, now before I move on to the next part, रोहिल ने लिखा था अनडिफ्लेक्टेड बहुत पहले. तो यार वो जो अनडिफ्लेक्टेड का टर्म है ना जो रोहिल ने लिखा था, इफ यू रिकॉल, तो इसके अंदर जाकर एक कंडीशन अराइज करती थी where the magnetic force and the electrical force used to balance out each other. And when that used to happen, then we used to say that the charged particles will go undeflected. See? So last part mein bas the question is asking you, explain why potential difference causes a force on the moving electrons. अब देखो वर्डिंग क्या पूछी है. Explain why this potential difference causes a force. Break down your answer into 2 steps. Based on E is equal to V upon T, the AS formula, potential difference gives rise to electric field. First pointer. आंसर किस तरह से देना है वो देख लो. Based on E is equal to V upon D, potential difference gives rise to electric field. Then the second statement. Based on F is equal to EQ. अब काफी स्टूडेंट्स, बिफोर आई कंटिन्यू, काफी स्टूडेंट्स पूछते फॉर्मूला मेंशन करना जरूरी है. टेक्निकली नहीं, फॉर्मूला मेंशन करना जरूरी नहीं है. ये मैंने आपकी कन्वीनियंस के लिए लिखा है ताकि जब आप रीड करो तो आप जज कर सको व्हाट आई एम डीलिंग विद. बट यू डोंट हैव टू राइट डाउन द फॉर्मूला. याद हो तो अच्छी बात है, मैंने लिख दिया है ताकि आप रिलेट कर लो. बट द क्वेश्चन इज ओनली आस्किंग फॉर द वर्डिंग्स रादर देन द फॉर्मूला. सो बेस्ड ऑन F is equal to EQ, this electric field exerts a force on the electron. So फॉर्मूला जरूरी नहीं है. The only reason I've mentioned these formulas is ताकि थोड़ा सा relatable हो जाए. When you read the statement, जरा समझना आसान हो जाता है आपको कि based on E is equal to V upon D, potential difference gives rise to electric field, the AS वाला formula. And then again, the AS वाला formula, based on F is equal to EQ, this electric field exerts a force on the electrons. Next question. अच्छा, इस टॉपिक के काफी क्वेश्चंस हैं, तो टू अ लार्ज एक्सटेंट मैंने क्वेश्चंस करवा दिए हैं, और कुछ क्वेश्चंस पर होमवर्क में भी सॉल्व दे दूंगा इसी फॉर्म में, तो वो प्लीज आप लोग खुद देख लीजिएगा. फिर मुझे नेक्स्ट वाली क्लास में इलेक्ट्रोमैग्नेटिक इंडक्शन स्टार्ट कराना है, सो होपफुली आई स्टार्ट विद दैट वर्किंग इन द नेक्स्ट क्लास. तो जितने करा सकता था मैंने करा दिए. ऑलमोस्ट इक्वल नंबर ऑफ क्वेश्चंस दे भी दूंगा घर पे रीड करने के लिए. स्टेटमेंट्स आप लोग पढ़ लो. रीड कर लो. पार्ट ए और पार्ट बी आई गेस आप लोग खुद ही फॉलो कर लो. मैं पार्ट सी से वर्किंग करा देता हूँ. It says a charged particle of mass m and charge minus q traveling through a vacuum at a constant speed. It enters magnetic field. The initial angle is 90 degrees. Once again, they are asking you why the path is going to be an arc of a circle. ठीक है, the same wordings kind of. Second part के अंदर they are asking us to show that q upon m is equal to v upon br. So I've done that working. आप सिर्फ स्टेटमेंट्स को रीड कर लो, आई गेस फॉलो हो जाएगा. ठीक है, मैं अब थर्ड पार्ट पे, सी वाले पार्ट पे मूव कर रहा हूँ. So the initial speed is given to us. The magnetic flux density is also provided, and the radius of the arc is also given. The question is asking you to obtain the ratio of q upon m. So from the previous part, बस directly कर लेना velocity. यार अली, if you have a calculator ना बेटा, जरा मुझे आंसर दे दो. So velocity, radius, and magnetic flux density. Sorry, मैंने actually आंसर मिटा दिया था, बल्कि I don't think I need it. नहीं, I think I need it. 10 का पावर मिसिंग है. I know 1.78 तो आएगा. सॉरी, मैंने वो इरेज आउट कर दिया है. जी, या आयशा असिस्ट कर देगी. या अली कर देगा या रोहेल कर देगा. थैंक यू. कूलम्स पर किलोग्राम. नेक्स्ट पार्ट देख लेते हैं यार. आप रीड कर लो. It says the path of negative charges. So this is the path of negative charge. Um, Before it enters the magnetic field is given to us. The direction of the magnetic field is into the plane of the paper. So first finger points into the plane of paper. Second finger, again remember second finger denotes current. Current is the flow of positive charges. The negative charges are moving to the right, and current, which is the flow of positive charges, must point to the left. ये important है, जरा याद रखना. First finger for magnetic field, that is into the plane of the page given to us in the question. Second finger represents current. So if negatively charged particles are flowing to the right, if negatively charged particles are going to the right, and current, which is the flow of positive charges, must point to the left. Try pointing the first finger into the screen. Try pointing the second finger to the left of the screen. और अगर आप लोग फर्स्ट फिंगर को पॉइंट करोगे इनटू द स्क्रीन, आपको रिस्ट को रोटेट करना पड़ेगा. सेकंड फिंगर को पॉइंट करोगे टू द लेफ्ट ऑफ द स्क्रीन, एज आई सेड, हैंड को रोटेट करना पड़ेगा. यू वुड एक्सपेक्ट योर थंब to be pointing towards the bottom of the screen. तो जरा हैंड की प्लेसमेंट करके देख लीजिएगा. जो उमर ने लिखा है ना डाउनवर्ड फोर्स, इवन दैट्स फाइन. ठीक है, तो डाउनवर्ड भी सही है. अच्छा रोहिल, हाँ सही है, रोहिल की वर्डिंग भी सही है. सो फर्स्ट फिंगर for the magnetic field into second finger for the direction of current. So negative charges were shown to be traveling to the right. So positive charge must be traveling in the opposite direction, that is to the left. So try pointing the first finger into the screen. Try pointing the second finger to the left of the screen. So second finger points towards the left hand side of the screen. आपको wrist को थोड़ा rotate करना पड़ेगा, and then the thumb points downwards. That means charge particle होगा. You would expect the charge particle to follow an arc of a circle pointing in the downward direction first of all. तो थोड़ा सा appropriate बना लो. So keep curving it for as long as it is within the magnetic field. It's a curved path for as long as it is within the field. And make sure as soon as it exits the field, then the path should get straightened out. Distinction कर लो. They are giving you 2 marks. जरा दोनों चीजों को factor in करना. So long as it's traveling through the magnetic field, it follows a curved path. And as soon as it exits the field, तो जब वो exit करेगा, then the path becomes straight. ठीक है, so no field, therefore no force. So that should be tangentially straight. So curved path for as long as it stays within the field, and then the path kind of straightens out as soon as it exits the field. और I guess यही पूछा हुआ था. Sketch the path of the particle in the magnetic field and as it emerges from the field. ठीक है, सो इन द फील्ड and as soon as it emerges from the field, so both factors have been taken into consideration. ये येलो हाइलाइटेड लाइंस इरेज करके नेक्स्ट वाले पे मूव कर दो। अच्छा, ऑलमोस्ट इतने ही क्वेश्चंस फिर मैं अपलोड कर दूंगा फॉर योर होमवर्क एज वेल, वो फिर आप लोग खुद देख लेना। सो ये वाली स्लाइड पे तो ये सारे क्वेश्चंस हमने भी आज किए हैं, तो जरा घर पे टाइम मिले तो प्लीज इन सारे क्वेश्चंस को देख लेना, और मैं दूसरी वाली स्लाइड के क्वेश्चंस अभी स्टार्ट करा देता हूँ। ठीक है, ये सारे अभी किए, और दूसरी वाली स्लाइड पे मूव कर जाता हूँ, वो स्टार्ट करा देता हूँ। ओके, ये वाला क्वेश्चन जरा डिफरेंट है एज अपोज टू व्हाट वी हैव डन सो फार, तो ये वाला भी जरा एक करा दो। आप रीड पहले कर दो, स्टेटमेंट जरा रीड कर लेना। So in the diagram, it says the current in a long straight wire is in the direction x to y, as shown. So the current carrying wire is carrying current in the direction x to y. So the current is basically coming out. Sorry यार, ये वाला एक देख लो, फिर मैं conclude कर दूंगा. So the current is flowing in the direction x to y as shown in figure 6.1. The first part में sketch the pattern of the magnetic field in the horizontal plane ABCD due to the current carrying wire, and draw at least 4 field lines. ठीक है, so first part तो simple है. Since we know current is coming out, so current coming out is denoted by the symbol of dot. And if you recall, so current coming out के लिए the field points in the anti-clockwise direction. So far so good. मैंने diagram construct कर दिया, and the field lines have been correctly showed over here. Next part ये थोड़ा सा different है. It says, इसको थोड़ा carefully read कर लो B वाले part को. So in part B it says, मैं थोड़ा zoom in कर दूं आपके लिए convenient हो जाए. Okay. So part B के अंदर the current carrying wire is within the Earth's magnetic field. It further says, as a result, the pattern drawn in figure 6.1 is superimposed with the horizontal component of the Earth's magnetic field. The question is saying that since this wire is within the Earth's magnetic field, therefore, the field pattern drawn around the wire is going to get superimposed on the Earth's magnetic field. It then goes on to say, figure 6.2 shows a plane view of the plane ABCD with the current in the wire coming out of the plane. So notice carefully, current coming out of the wire is shown to you. I'm just making a pink circle around it. Ignore the point P. उसकी अभी जरूरत नहीं है. The wire shows you a current of the wire. So you know, जो diagram के ऊपर they have shown you that the current is coming out of the plane ABCD. That's the current carrying wire. And the diagram is also highlighted the Earth's magnetic field. Now the question goes on to say, ये एक पॉइंट ऐसा है जो उन्होंने इतने सालों में कभी पूछा नहीं है. थोड़ा सा जूम आउट कर रहा हूं. एंड द क्वेश्चन ओवर हियर इज आस्किंग यू, थोड़ा केयरफुली प्लीज देख लेना, स्पेशली द फर्स्ट पार्ट. ऑन फिगर 6.2, mark with the letter P a point where the magnetic field due to the current carrying wire the field due to the current carrying wire could be equal and opposite to that of the Earth. The question is saying, mark with the letter P a point where you would expect the field due to the current carrying wire to be equal and opposite to the magnetic field of the Earth. Okay. Up the field of the wire is shown in diagram 1. The field of the wire is shown in diagram 1. The Earth's magnetic field is shown in diagram 2. So one diagram is constructed by us, that's the field of the wire. And one diagram is given by them, that's the Earth's field. And the question is asking you to locate a point where you would expect these two fields to kind of balance out each other, equal and opposite. Can you all realize कि अगर मैं वायर की फील्ड को नीचे वाले डायग्राम पे सुपर इम्पोज करूं, which I'm doing right now. I'll shift it back, no worries, लेकिन पहले जरा देख लो इसका फायदा क्या है. If I were to shift the Earth's magnetic field and the wire's magnetic field, if I were to construct them on the same diagram, मैं इसको वापस ले जाऊंगा, but जरा carefully देखना, and I think you would all appreciate that the region which I'm marking, which is the region on the right hand side of the wire, इस जगह पर I think you would agree that the Earth's field and the field of the wire would both reinforce with each other. Or you can say that the two fields are going to add up with each other. Add up isliye because they are pointing in the same direction. So if you can just make some sense out of the wordings which I have stated, that the region shown on the right hand side of the wire, the one shown with the green colored marker, इस region के अंदर the Earth's field and the field of the wire are both pointing in the same direction. So you'd expect that the field in this region is going to reinforce, or the field is going to kind of add up with each other. However, the region which I'm marking right now, and that's the region on the left hand side of the wire. Look carefully to recognize कि इस region के अंदर we can expect the two fields to cancel out. The reason for that is the Earth's field is pointing upwards and the field due to the wire is pointing downwards. So if you want a region where the two fields are going to be equal and opposite, then the region must be to the left of the wire. मैं region अभी mark कर देता हूँ. So please let me, मैं repeat वापस कर दूँ, that the region on the right hand side of the wire, the one which I'm labeling it as 1. So in region labeled as 1, the Earth's field and the field of the wire kind of superimposes, or you can say adds up or reinforces with each other. तो region 1 के अंदर field का equal and opposite होने का sense नहीं बनेगा. But the region which I am now marking as 2, this is the region where the Earth's field appears to be in the opposite direction to the field of the wire. So if we are expecting a region where the two fields can be equal and opposite, that region must be located somewhere to the left of the wire. If you're okay with this terminology, मैं पहला काम ये करता हूँ कि let me take the wire's field back to its original diagram, and then I can mark a region. Just give me a second. मैं इसको वापस से टॉप पे ले जाता हूँ. ठीक है, that was the original diagram. I've just shifted it back. And the question was asking us to mark and label a point. So the point should be located somewhere on the left of the wire, as I've marked and illustrated over here. The question was asking us, अब मैं इसको zoom in कर रहा हूँ, तो अब read कर लो वापस से. So the question said, On figure 6.2, mark with the letter P a point where the magnetic field due to the current carrying wire could be equal and opposite to that of the earth. So guys, थोड़े से लोग जरा मुझे ओके कर दोगे कि यू हैव अंडरस्टूड कि मैंने ये वाला पॉइंट लेफ्ट की तरफ क्यों लोकेट किया है. ठीक है, मैं रिपीट वापस कर रहा हूँ कि ऑन द राइट हैंड साइड the two fields will kind of superimpose, or the two fields will reinforce, or the two fields will add up with each other. Whereas on the left hand side, the earth's field was pointing one way and the wire's field was pointing the other way. So there was a likelihood that the two fields will kind of nullify each other. Arich is asking, does the position matter on the left though? No, it doesn't. So anywhere on the left. ठीक है ना? So what matters, 1 mark इसीलिए दिया है because they are just checking whether you're marking the point on the right side of the wire or not. So anywhere, um, as long as it's on the left hand side of the wire. ठीक है. Second part इसका एक करा दूं. आप part 2 को read कर लो. So the question then says that for a long straight wire, the field strength is given by this equation. This is the same formula that we did in the notes as well. However, notes के अंदर, if you remember, if you want, I can show this formula to you right about now. But notes के अंदर, this is how I wrote down the formula. Mu naught I divided by 2 pi d. Okay, so I took the distance as d, and in this formula, they've taken the distance as r. सही तो खैर कोई फर्क नहीं है, it's the same thing. Uh, in the notes, we used the formula d, the symbol d for distance, and out here they are using the symbol of r for the distance. Let me just quickly show you this formula before I proceed further. Okay, नजर आ रहा होगा. ठीक है, मैं जो कह रहा था कि मैंने d यूज किया था for distance. The formula is still the same, just the difference being कि उन्होंने d की जगह r का symbol use किया हुआ है. Anyways, the question says okay, the question says that the point P is found to be 1.9 centimeters from the center of the wire when the current was 1.7 amperes. Okay, so for a value of current 1.7, this point is located at a distance of 1.9. And the question is asking us, calculate a value for the Earth's magnetic field. So based on these details, you are expected to calculate a value for the Earth's magnetic field. Now, mind you, this formula will not provide me with a value for the Earth's magnetic field. But this formula will surely provide me with the value of the magnetic field associated with the wire. So this formula is not meant to give me the Earth's magnetic field, but certainly this formula is useful enough to help me locate the strength of the magnetic field associated with the wire. So if I use these values, I can at least calculate the answer for magnetic field strength associated with the wire. So मेरा आंसर आ रहा है 1.8 times 10 to the power of 5 after plugging it all these values given to us. Now, since we know that at the point P, the Earth's magnetic field is equal to the magnetic field of the wire, so I can use the same answer for the Earth's magnetic field as well. Okay, so let me repeat myself. This formula essentially gives me the field strength associated with the wire. The question, however, is asking me to calculate the field strength associated with the earth. The fact that at the point P, both of these fields were numerically equal in terms of magnitude, so I can use this formula to calculate the field associated with the wire, and coincidentally, the same answer is also going to be valid for the magnetic field strength associated with the earth, because at the point P, they were both identical to each other. ठीक है guys, यहाँ पर ओवर कर रहा हूँ. So next वाली class के अंदर I intend to start with electromagnetic induction, and as homework you guys go through all these questions. I'll just upload these questions in a bit. So जब time मिले please कर लीजिएगा इन questions को go through. ठीक है यार, take care and खुदा हाफिज़ for today.